This is a Level 2 Functional Skills Maths paper from NCFE. It's split into two parts. In the first part, you can't use a calculator, but you can in the second part. Activity 1, swimming. Asha often goes swimming at Upton Leisure Centre. She pays £5.20 each time she swims. Next month, the price will increase by 12.5%. How much more will Asha need to pay for each swim? Give your answer in pence. As we're going to need to give the answer in pence, I'm going to convert £5.20 into pence, which is 520 pence. So we need to work out 12.5%, and as we are not using a calculator, I'm going to use the 10% method. So 10% of 520, that's worked out by going 520 divided by 10, which means knocking off a 0 in this case, so that gives us 52. So we've got 10%, need to work out 2.5% now. So 5% would be half of 10%. 2.5% would be a quarter of it. So we're going to need to work out a quarter of 52 to get 2.5%. So 52 divided by 4. How many 4s would fit into 5? That would be 1. And we would have 1 remaining. How many 4s into 12? That would be exactly 3. So a quarter of 52 is 13. To get 12.5%, we're going to combine the 10%, which is 52, and the 2.5%, which is 13. Adding them together, we get 65. So the answer is 65 pence. £5.20 is 30% more than the price at Downton Leisure Centre. Calculate the price at Downton Leisure Centre. So, if the price at Downton Leisure Centre, represent here by 100% before the increase, now £5.20 would be 30% more. So 130%. Which is also 520 pence. So to get the 100% amount, what we're going to do is divide the 520 by 130 so that we can get 1%, and then multiply by 100. So 520 divided by 130. How many 130s would fit into 520? If we count them up, 130 and 130, that would give us 260. If we add another 260, that would give us 520. So it's 4 lots of 130 that fit into 520. In other words, 4 is the 1% amount. What about the 100% amount? That would be 4 times 100, which is 400. And we used pence, so we get out pence. 400 pence is equal to £4. The pool where Asha swims is rectangular. It is 2,500 centimeters long and 1,250 centimeters wide. The four sides of the swimming pool are 150 centimeters deep. They are covered with small square tiles of different colors. Each small tile has an area of 1 centimeter squared. Asha thinks there must be over 1 million small tiles covering the sides of this pool. Is Asha correct? Explain how you decide. As each small tile has an area of 1 centimeter squared, if we work out the area overall in centimeters squared, we would find out at the same time how many of these small tiles fit in there. So let's have a look. We've got the dimensions, and that is 1,500 centimeters long and 1,250 centimeters wide. So if I try and sketch this very quickly here, we'd have the length being 2,500 centimeters, the width being 1,250 centimeters, and the depth being 150 centimeters. So if we look at each of the sides of the swimming pool, let's take this one first. The dimensions of that would be 2,500 centimeters by 150 centimeters. So if we try and multiply 25 by 15, 5 times 5 is 25, 5 times 2 is 10, and 2 is 12. Putting 0 down, 1 times 5 is 5, 1 times 2 is 2. Adding them together, 375, and we add the zeros that are left, so we've got 3 zeros. There are 2 sides which are identical, so that's this one as well, which would have the same area. So we're going to add another lot of this. So 750,000 so far. And we've got 2 other sides which measure 1,250 by 150. So again, we're going to multiply 125 by 15 and then add the zeros. So 125 times 15. 5 times 5, which gives us 25. 5 times 2, 10, and the 2, 12. 5 times 1 is 5, and the 1, 6. Putting 0 down. 1 times 5 is 5. 1 times 2 is 2. 1 times 1 is 1. Adding them together. 5, 7, 8, 1. Now adding the 2 zeros. And as we can see, that 2 of them that are both sides identical, so we're going to add another lot of this. So 375,000. Now adding the 2 areas together, which means the four sides. Seven and 5 is 12. So 1,125,000. And the question was, Asha thinks there must be over 1 million small tiles covering the sides of this ball. Is Asha correct? Yes, because this is 1,125,000 centimeters squared. And as we said, one tile is equal to just 1 centimeter squared, has an area of 1 centimeter squared. So there must be 1,125,000 small tiles. So yes, she is correct. Asha reads that the women's Olympic record for swimming 100 meters is 52.7 seconds. This means that the record holder swam at an average speed of 1.9 meters per second. A goldfish can swim at a speed of about 0.9 miles per hour. Did the Olympic record holder swim faster than a goldfish? Show how you decide. This conversion graph will help you. So let's convert this from 0.9 miles into kilometers. So 0.9 miles would be here. So this is 1.1, 1.2, 1.3, 1.4, 1.424. So this is 1.44. Let's get it into meters now, convert it into meters, because that's how we're given the other speed. So 1.44 kilometers into meters. So 1 kilometer is equal to 1,000 meters. What about 1.44 kilometers? So we need to multiply it by 1,000, which means moving the decimal point 3 places to the right, so we get 1,440 meters. But when this was given to us was in miles per hour, and we need to convert it into meters per second. We've so far converted the miles into meters, but we also need to convert the hours into seconds. So how many seconds would that be in 1 hour? There are 60 minutes in 1 hour. And there are 60 seconds in 1 minute. So 60 times 60 would give us how many seconds there are in 1 hour. So that is 3,600. So we've got the numbers that we need. 1,440 So what we've done, we've converted this and we've got 1,440 meters per 3,600 seconds. We want it as meters per second, so per 1 second. So what we're going to do is divide 1,440 by 3,600 to get the answer per 1 second. So dividing both by 10, we get 144 over 360. We know that 144 is a multiple of 12 because 12 times 12 makes 144, so we can divide this by 12 to get 12, and again divide the 360 by 12 to get 30. Again, we can still simplify this further. If we divide both of them by 3, we get 4 over 10. And as we're going to write this in decimal form, just like we've got the 1.9, I'm going to convert this now to 0.4. So this is now 0.4 meters per second. And the question was, did the Olympic record holder swim faster than a goldfish? Yes, because they swam at 1.9 meters per second, whereas a goldfish swims at 0.4 meters per second. So the answer is yes. Asha swims 1 kilometer each time she goes to the pool. She always records how long this takes her. The table shows her data for 10 swims. Time taken to swim, 1 kilometer in minutes, and the number of swims on the right. Estimate Asha's mean time to swim 1 kilometer. So in between 25 and 26, the midpoint would be 25.5. Midpoint between 26 and 27 would be 26.5. Between 27 and 28 would be 27.5. So we're going to multiply them across. So 2 lots of 25.5 4 lots of 26.5, so 4 times 5 is 20, 4 times 6 is 24 and the 2 is 26, 4 times 2 is 8 and the 2 is 10, so 106, 27.5 times 4, 4 times 5, 20, 4 times 7, 28 and the 2, that makes 30, 4 times 2 is 8 and the 3 is 11. Adding them all together, so 267. Number of swims is 10, so we're going to divide 267 by 10, which gives us 26.7. Moving the decimal point one place to the left to make this number smaller. So that's the estimation. And this is the end of this part.